For an example like this, there's a variety of methods that you can use, and I encourage you to use the method that works for you. So one thing I would say though is in this exercise, mark your work after every question. That way, if your way of working something out isn't actually getting you the right answer, you can modify it nice and early and come up with methods that do work. A 5-digit number is chosen at random. Find the probability that it is at least 60,000. All right, so we need to think of all of the 5-digit numbers that are 60,000 or bigger out of the total number of 5-digit numbers that there are. Now, two strategies I want to show you here. One is to say, well, let's consider each digit one at a time and what the possibilities would be. If it's got to be at least 60,000, then it could be 6, 7, 8, or 9 in that first digit position. So that's 4 different choices that we have. But for all of the other columns here, these other 4 columns, there's 10 digits that are possible, everything from 0 up to 9. And so we've got 10 times 10 times 10 times 10, which I can write cleverly like that. All right, how many 5-digit numbers are there altogether? Well, what choices do we have for the first column? Now we need to think. There's a trick here. The first column can't be a 0 because if it is, then it'll only be a 4-digit number, right? So the first column has to be 1, 2, 3, 4, 5, 6, 7, 8, or 9, and that's only 9 different choices. And then the other columns can be anything out of all 10 digits. So we end up with this. And we can clearly see that these will cancel and we just get 4/9. Now, another way to do it would be just to consider all of the numbers and effectively count them. Now, this is a good method, but a word of caution. People mess up all the time when they're counting from 0. Why? Well, because we naturally learn to count by saying 1, 2, 3, 4. And so we like counting things that start with a 1. Let me give you an example. If I say how many digits are there from 0 to 4, including 0 and 4, people will really commonly say, oh, it's 4, obviously, when it's actually 5. Why is it 5? Well, 0 is the first number we want, and then we've got 1, 2, 3, and 4. There's 5 digits there altogether. Now, if you're considering how far it is from 0 to 4, you would say that it's 4 jumps. So when we do 4 minus 0, sure, we get 4. But if we're wondering how many actual places there are, now we're including the beginning one and the end one. And that means we need to add 1 to this subtraction idea. So working with this, I think now you'll see what I mean when I transfer it to saying, well, how many numbers are there from, say, 60,000 up to 99,999? Well, we're starting counting on a 0. So we've got this problem here that many people will look at this and go, oh, I know, I'll just do 99,999 minus 60,000. Now, the problem with that is if you subtract these two, like this, then what you're going to get is 39,999. And you're possibly forgetting that you're counting both numbers. So you need to add 1 to get the correct answer of 40,000, which is what we considered up here. And similarly, when you're wondering how many numbers there are from 10,000 up to 99,999, you need to add 1 for that whole idea that you're starting on a 0. Now, another way that you could do it is say, hey, this is the same as the number from 10,001 up to 100,000. Why is that easier? Well, in a way it's easier because we're starting counting on a number that's got 1. So if we start counting on 1, by the time we get to 10, we've got 10. That's easy. So if we're starting on a 1, by the time we get to 10, you can see that we've got something that ends in a 0. And that reminds us that we've got 40,000, or in this case, 90,000 numbers altogether. So be careful when you're counting, especially if you're starting on a 0, because it seems really obvious and easy, but it's going to be the cause of many mistakes. All right, what's the probability that it consists of only even digits? All right, well, let's use this method of sort of acting it out, I suppose. If we've only got even numbers to choose from and it needs to be a 5-digit number, we've already considered it can't start with a 0. So it could start with 2, 4, 6, or 8. There's 4 choices there. What about the next 4 columns? Well, they could be 2, 4, 6, 8, or 0. So there's 5 choices for all of those. So we have 5 times 5 times 5 times 5, which I can write like that. Now on the bottom, we've already considered how many numbers there are altogether that have 5 digits in them. There's this many. And so now we can throw that into our calculator and it should come out with 1/36. So quite straightforward, just thinking through the possibilities for each digit. All right, what's the probability that no digit is repeated? All right, well, how many possibilities are there for the first digit of a 5-digit number? 9. What about the second one? Well, there's going to be 9 again, isn't there? Because the first one can only have 9 because it can't have a 0. Whereas the second digit, it could have a 0, but it can't have whatever you've already used in the first column. So there's 9 choices for that second column. Now, that's a little trick there. A lot of people just go 9 times 8 times 7 times 6, etc., and not realize that by thinking through the limitations of each digit, you'll get the right answer. All right, on the bottom, we've got the same as each other time. There are 90,000 numbers possible altogether, and this should give you 189/625. Again, leave your answer as a fraction if you can, because it's exact and it saves having to round it off. Now the last question's a really hard one, and the reason it's hard is because none of the methods that we've used so far really help us to solve it. We need to find the probability that no digit is repeated and the digits are in increasing order. Now the problem is, coming after C, we're kind of tempted to use this result somehow because it seems like it's going to be related. The problem is it's not, and I'll explain why it's not. It's because here we considered that we couldn't use 0 for the first digit, but we could perhaps use 0 for the others. Whereas down here, if we are putting the digits in increasing order and we can't start with the 0, we're not going to be allowed to use the 0 at all. So all of the numbers involved in this result are going to lead us astray. So instead we need to sort of reconsider. Now, one way of doing this is just to imagine any 5-digit number that has digits not being repeated. Let's just picture one. Just give a random number that doesn't repeat any of its digits. Now, there's only one way that we can arrange this so that the digits are in increasing order. I'd need to start with the 2, then have the 3, then the 5, then the 7, then the 8. There's only one way that that can be done. So just by looking at one number as an example and considering how I would arrange it in increasing order and thinking of the number of ways that I could do that, there's only one way. I know that because I'm not repeating any of the digits, and I'm only allowed to use 9 different digits because the 0 won't be allowed, all I really need to do is consider how many ways I can choose 5 different digits out of 9. Because any selection of 5 digits out of 9, I can then arrange so that it's in increasing order one way. So my working for this, once I've thought all of that through, would be to say I've got 9 choose 5 ways of picking my 5 digits, only one way of arranging them, out of the 90,000 5-digit numbers that there are altogether. And this will give me 7 5,000ths of a chance. So my advice then in answering one of those really tricky sorts of questions where none of the usual methods seem to apply would be fall back on your problem-solving strategies. Can I use an example? Can I draw a picture? Can I ask myself an easier question to answer a harder question? And once you've done some of those, often a method will come to you. It might not be the same method as the person next to you, but as long as you've both got the right answer, it's a good method. Now, don't forget in this exercise that you've also learnt methods for cutting down the number of ways you can choose items when some of the items are identical. All of that will come into play.